In this video, we're going to look at the three states of matter, the properties of those states of matter, and explanations of those properties in terms of the particles. And we're going to look at changes of state as well. Pause the video to do these 5 introduction questions. Press play once you've done them. You should have now done these 5 introductory questions. I'm just going to start by going through 4 and 5. So for question 4, the melting point of water is 0 degrees Celsius and the boiling point of water is 100 degrees Celsius. And for question 5, in what state of matter is water at -4 degrees Celsius? It will be a solid. You might have said ice, but it was asking you for the state of matter, so you have to call it a solid. And that's because -4 degrees Celsius is below melting point being 0. For questions 1, 2, and 3, the particle diagrams, they are here. So this one over here is a solid, this one is a liquid, and this one is a gas. So just a few rules for when you're drawing these particle diagrams. So when you draw the particle diagram for a solid, have at least 9 particles. Make sure they're all touching. Make sure there's a regular arrangement, so they're in lines like soldiers. And make sure that they touch the bottom. Make sure there's no overlapping, so there should be no overlapping of the particles. For the liquid, again, make sure there's at least 9 and make sure that they are all touching. But this time there is not a regular arrangement. So they're just in a mess. Not regular arrangement. And again, they also fill from the bottom, same as solid, and no overlapping, same as solid. And finally, for a gas, this time you just need at least 3, and they need to be not touching at all. So they need to be far apart. And again, no overlapping. And they don't need to be touching the bottom this time. The one that people get the most wrong is the diagram of a liquid, because they do the particles overlapping or they leave big gaps between the particles. So for example, people might draw a diagram like this for a liquid. This is a very common type of thing that we see. They do a big string of particles. That's not what a liquid looks like. That's not what the particles in a liquid look like. The particles in a liquid are closely packed, just like in a solid, but they're able to move. In a solid, the particles can only vibrate on the spot, so they stay in their fixed positions. In a liquid, the particles are still really close together, but they can move around now. An analogy is, think about a load of people crammed into a room. Now imagine they're all in rows, standing like soldiers in a room. That's like the particles in a solid. Now imagine all of those soldiers, still the same amount of soldiers, still packed in the room, but now they all start to walk around. So they're still really closely packed together, but they're able to move around. That's what the particles in a liquid look like. So to really understand this topic, states of matter, we need to understand what I mean when I'm saying particles. So when I'm talking about particles, I'm talking about atoms. I'm also talking about molecules. I'm also talking about ions. When I'm talking about the particles in a solid, in a liquid, or in a gas, I'm talking about individual atoms. I'm talking about groups of atoms together. So for example, a molecule made of 3 different atoms. I'm talking about ions, which might have lost or gained electrons, but I'm just talking about these little tiny pieces of matter. So when I'm referring to particles, if I'm talking about the particles in pure copper, I might be talking about ions. If I'm talking about the particles in pure water, I might be talking about molecules. But either way, I'm talking about particles, little tiny bits of matter. So let's firstly have a look at the particle arrangement in solids, liquids, and in gases. So in a solid, we're going to look at the arrangement, the motion, the kinetic energy, the forces. So what I want you to do is please pause the video, try and fill in as much of this table as you can by yourself. Press play once you've done it. You should have now had a go at filling in this table yourself. Please mark and correct your work as I go through it, and definitely include the key points that I write down in each box. So the arrangement of the particles in a solid, they are closely packed. They are very closely packed. It's what we call a regular arrangement, because as you can see, they're in nice tidy rows. The motion of the particles, they vibrate on the spot. So they don't move around like in a liquid or a gas. So they vibrate on the spot. Their kinetic energy is low. So their kinetic energy is low. And the forces between particles are very strong. In a liquid, the particles are still closely packed, but they're not in a regular pattern. They're not in a fixed regular pattern, but they are still closely packed. Their motion, they can move around, so they're free to move around. And their kinetic energy is higher than in a solid. And the forces between the particles are weaker than in a solid. And that's why the particles can move around. And finally, in a gas, the arrangement of the particles, they're far apart. Their motion, we say that they move freely. So they move freely, and they also move randomly. That means that they have different speeds and directions. So each particle will be moving at its own speed in its own direction. Another particle might be moving slower or faster in a completely different direction. And the kinetic energy of the particles is high. Forces between the particles are negligible. There is basically no force between the particles at all. So please mark your table, make the corrections, press play once you've done that. So you should now have a completed table of the arrangement, motion, and forces of the particles in solids, liquids, and gases. So let's move on to use these properties to explain to use these arrangements and motions and forces of particles to explain the properties of solids, liquids, and gases. So the first property we're going to explain is compression. So which of solids, liquids, and gases can be compressed? Say your answer to the video now. So you should have said only gases can be compressed. Some people think liquids can as well, but they can't. Only gases can be compressed. And that's because when you look at the particles in a solid, they're too close together. There's no room for them to get closer together. If you look at the particles in a liquid, they're too close together. There's no room for them to get closer together. Only the particles in a gas can get closer together. If I've got the particles in a gas and I want to cram them into a smaller container, I can. These are the same particles, the same size. That's something I didn't say earlier. When you draw particle diagrams, you need to make sure all your particles are the same size. So I can cram those particles closer together, and that's because there is space between the particles for the particles to get closer together. In solids and liquids, there is not. Next property, taking the shape of the container. Which of solids, liquids, and gases take the shape of their container? Say your answer to the video now. You should have said liquids and gases. Solids can't. So liquids and gases can take the shape of the container. The reason why is the forces between particles and liquids and gases are weak, which means the particles are free to move around. Therefore, they can take the shape of any container. So liquids and gases take the shape of container because the forces between particles are weak. So the particles are free to move around. In a solid, the forces are strong, very strong. So therefore, the particles cannot move around, they just vibrate on the spot. So there's no way for the solid to take the shape of the container. Next property, flow. Which of solids, liquids, and gases can flow? Say your answer to the video now. You should have said that only liquids and gases can flow. And that's because liquids and gases have weak forces between the particles. So the particles can move over each other or around each other. So the particles are free to move. In a solid, the particles are all strongly bonded together by forces, and they just vibrate on the spot. So a solid cannot flow because those particles are all stuck together. Next, conductors of heat. Which of solids, liquids, and gases are the best conductors of heat? Or which one is the best conductor of heat? Say your answer to the video now. So the one that's the best conductor of heat is solid. So solids are the best conductors. Also true of electricity, actually. So solids are the best conductors because the particles are closer together than in liquids and gases. For conduction to happen, particles need to bump into each other to pass the energy between them. That's best in solids because in solids, the particles are closest together. This is actually the reason why sound travels faster through solids than it does through liquids and gases as well. So sound can travel faster through solids because the particles are closer together, so those vibrations can be passed on quicker. Last example, expansion. So all three, solids, liquids, and gases, so any of those substances expand when they are heated. A really important point here is that the particles do not expand. The particles do not expand. The particles themselves have exactly the same size and shape, but let's say we have a solid. So here's a solid. When we heat it, those particles move apart slightly. So they move apart slightly. They do not get bigger. There is now a slightly bigger gap between them. There's still the bonds. They're still being held together, but they've moved apart. So the substance expands. So if you heat up, for example, a piece of iron, the iron will get slightly bigger. The particles themselves have not changed size, just the iron, the overall substance, has got bigger because the particles move further apart. So please pause the video to do these questions. Press play once you've done them. You should have now done these questions. Pause the video to mark question 1. Press play once you've done that. You should have now marked question 1, checking very carefully that your pictures match with the key features listed. If you've not yet done that, if you've not yet checked that your diagrams actually match with each of the key features, so for example, particles are all touching, regular arrangement, all particles the same size, draw at least 9, bottom of the box, particles are not overlapped. If your diagram does not match with every single one of those key features, you need to draw a corrected one. Pause the video to do that, press play once you've done that. You should have now fully marked and corrected your diagrams. Please pause the video to mark the rest of those questions, press play once you've done that. So you should have now marked the rest of those questions, so we can now move on to changes of state. So if you start with a solid, if you heat that solid, it will get hotter and hotter and hotter and hotter, and eventually it might turn into a liquid. And if you continue heating it, eventually it might turn into a gas. This change from a solid to a liquid is called, say your answer to the video. Hopefully you said melting. And the change from a liquid to a gas, what's that called? Say your answer to the video. You might have said evaporating, but we're going to call it boiling, and later I'm going to explain the difference between evaporating and boiling. If you cool a substance down, a gas can turn into a liquid. What's that change called? Say your answer to the video now. That's called condensing. And a liquid to a solid, what's that called? Say your answer to the video now. That's called freezing. You can also have a change straight from solid to gas. So a solid can turn directly into a gas. That's got a name, which is sublimation. So those are the changes of state. When you heat things up, they can melt, which is a solid turning to a liquid, or boil, which is a liquid turning to a gas. And when you cool things down, they can condense, which is gas turning to liquid, or freeze, which is liquid turning to solid. So let's just quickly check that you know what those words mean. What is the name of the state change from liquid to gas? Say your answer to the video now. You should have said boiling. What is the name of the state change from liquid to solid? Say your answer now. You should have said freezing. And what's the name of the state change from solid to gas? Say your answer now. You should have said sublimation. Next is melting points and boiling points. So the first thing to do is just define what a melting point is. So people think that melting point is the temperature at which something melts. It is, but it's also the temperature at which something freezes. So the melting point is the temperature at which something melts if you're heating it up. So it melts if you're heating it, but it's also the temperature at which something melts, at which something freezes, if you're cooling it. So it's the temperature at which something melts if you're heating it, and the temperature at which something freezes if you're cooling it. Can you write a similar definition for boiling point? Pause the video to do that, press play once you've done it. You should have now written a definition of boiling point. So boiling point is the temperature at which something boils if you're doing what? You should have said if you're heating it. And condenses if you're doing what? You should have said cooling it. Now I've done some examples. So the melting point of alcohol is minus 114.1 degrees, and the boiling point of alcohol is 78.4 degrees. Now what that means is, at any temperature in between these two numbers, alcohol will be a liquid. If you're above 78.4, alcohol will be a gas. And if you're below the melting point, alcohol will be a solid. So, for example, if I asked what state of matter would alcohol be at 90 degrees Celsius, the answer is it would be a gas, because 90 degrees is above 78.4. If I asked what state of matter would alcohol be at minus 35 degrees Celsius, the answer would be a liquid, because minus 35 degrees is between minus 114.1 and 78.4. Let's now have a look at lead. I'm going to write down a temperature, and you're going to need to decide what state of matter the lead will be at. So if we have lead and its temperature is 550 degrees, what state of matter will it be? Say your answer to the video now. The lead will be a liquid, and that's because it's between the melting point and the boiling point. What if the lead was at a temperature of 326 degrees Celsius? Solid, liquid, or gas? Say your answer to the video now. So the lead would be a solid because that's below its melting point. Let's now have a look at nitrogen. So here's the nitrogen. So if I have nitrogen, and my nitrogen is at a temperature of minus 194 degrees Celsius, what state of matter will it be in? Say your answer to the video now. You should have said that it will be a gas, because minus 194 is hotter than minus 195.8. So it's above the boiling point. It will therefore be a gas. Now, when we do state changes are examples of what we call physical changes. And that means that nothing new is made. So in a chemical reaction, something new is made. But in a physical change, nothing new is made. And also, the change is reversible. Meaning, if we have ice, which is a solid, and we melt it to make water, we can then cool down the water to turn it back into ice. If we have chocolate, which is a solid, and we melt it to make a liquid, we can then cool down the liquid chocolate to make it into a solid again. State changes are reversible. If you turn a liquid into a gas, you can turn the gas back into a liquid. That's not the same as a chemical change. In a chemical change, something new is made, and often chemical changes are not reversible. You can't get back what you started with. And the reason for this is when you have a state change, all you're doing is changing the arrangement of the particles. If this is a solid and I change it to a liquid and then to a gas, I've still got exactly the same particles, just the arrangement is different, the forces between the particles are different, and the kinetic energy of the particles is different. But the particles are the same particles. So when you do a state change, you don't change the particles themselves. You just change the arrangement, the motion, and the forces between the particles. That also means that mass is conserved in a state change, meaning the mass before a change of state is the same as the mass after a change of state. If you have a load of ice and you measure its mass, then you melt that ice and measure the mass of the water, it will be exactly the same. And if you then boil that water and trap the steam and measure the mass of the steam, it will be exactly the same. There won't be a change in the mass of the substance because you're not changing the particles. You're just changing their arrangement, their kinetic energy, and the forces between them. Finally, the difference between evaporation and boiling. So boiling happens at the boiling point. For water, that's 100 degrees. For other substances, it's different. Boiling points of different substances are different. They're not all 100 degrees Celsius. Only the boiling point of water is 100 degrees Celsius. So the boiling happens at the boiling point. And when you get to the boiling point, all the liquid will turn into a gas at that temperature. So for example, at 100 degrees, water turns to steam. That's boiling. Evaporating can happen at any temperature. So if you have some water and you put it in a room at room temperature around 20 degrees, if you leave that for long enough, that water will all evaporate. And that means it's slowly turning into a gas. And what happens, it's just the water at the surface. So e.g., water at 20 degrees, particles escape from the surface of the water over time. So if you put a lid on it, the water wouldn't be able to escape. But if you've just got an open cup of water, if you leave it, the particles in that water, the ones at the surface, will escape because some particles have more kinetic energy than other particles, and the ones with enough kinetic energy can escape from the surface. And over time, evaporation happens. But they're two different things. Boiling happens at the boiling point. When we talk about changes of state and changing things temperature and getting things to boil, that's happening at the boiling point. Evaporating is just something that happens at any temperature, any time, and we're not going to be talking about that as much in this topic. So please pause the video to do these questions. Press play once you're ready. You should have now done these questions. Pause the video to mark them. Press play once you've marked and corrected them. You should have now marked and corrected these questions. Pause the video to do these questions. Press play once you've done them. You should have now done these questions. Pause the video to mark and correct those questions. Press play once you've done that. You should have now marked and corrected those questions. Pause the video to do these questions. Press play once you've done them. You should have now done these questions. Pause the video to mark these questions. Press play once you've done that. You should have now marked these questions. Pause the video to do these questions. Press play once you've done them. You should have now done these questions. Pause the video to mark and correct these questions. Press play once you've done that. You should have now marked and corrected those questions. So in this video, we've looked at the states of matter, solid, liquid, and gas. We've looked at why the states of matter are the way they are in terms of the arrangement of the particles, the motion of the particles, the kinetic energy of the particles, and the forces between the particles. We've looked at various properties of solids, liquids, and gases and explained them. We've looked at changes of state, we've looked at the names of the changes of state, and we've also understood that mass is conserved because the particles themselves don't change, and changes of state are physical changes which are reversible because the particles themselves don't change. Just the arrangement, the forces between the particles, and the motion of the particles change, which is how solid, liquids, and gas can change state. We also looked at boiling points and melting points and how to know if a substance is a solid, liquid, or gas at various temperatures. And we also looked at the difference between evaporation and boiling. I hope this video was useful. Please like and subscribe for more videos on GCSE physics.